If you stood on the surface of Mars today and took off your helmet, you wouldn't just suffocate. Because the atmospheric pressure is so low, less than 1% of Earth's, the boiling point of your blood would drop below your body temperature. Your saliva would turn to steam on your tongue. Within seconds, your skin would swell as the water in your tissues turned to gas. We talk about Mars like it's a fixer-upper home, but the truth is, Mars is a planet-sized vacuum chamber designed to pull you apart.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
It's easy to dismiss this as billionaire science fiction. But every breakthrough we make in trying to survive on Mars, like turning carbon dioxide into breathable oxygen or recycling 98% of human waste into drinking water, is a technology that we desperately need right here. If we figure out how to thrive in a place that has nothing, we finally learn how to stop wasting everything we have on Earth. But before we solve Earth's problems, we have to face the first hurdle: the 6-month silent box. The journey to Mars is a slow-motion car crash for the human body. Without gravity, your heart, which is a muscle, doesn't have to work as hard to pump blood. It actually begins to shrink and change shape, becoming more like a sphere than an oval. Your fluids shift toward your head, giving you a puffy face and causing permanent vision damage as pressure builds behind your eyes. By the time the hatch opens on the red planet, you aren't a conquering hero. You're a patient in need of intensive physical therapy. But physical decay is manageable. What happens when the 7 minutes of terror begins? Landing on Earth is easy because our thick atmosphere acts like a giant brake. Landing on the Moon is easy because there's no air, so you just use rockets. Mars is the worst of both worlds. The atmosphere is thick enough to create deadly heat during entry, but too thin to slow you down with a parachute. Engineers call this the death zone. You have to hit the atmosphere at 13,000 miles per hour and somehow stop in just 7 minutes using supersonic retropropulsion. One math error, and the multi-billion-dollar colony becomes a new crater. If you survive the landing, you'll step out into a world that smells like a spent firework. Why? Martian dust isn't like the sand at the beach. On Earth, wind and water round off the edges of sand grains. On Mars, the dust is jagged, like tiny shards of glass. It's also statically charged, meaning it clings to everything: solar panels, camera lenses, and your lungs. But the real danger is chemical. The soil is saturated with perchlorates. On Earth, we use these to make rocket fuel. On Mars, if you breathe even a tiny amount of this dust, it shuts down your thyroid gland. You can't just walk on Mars. You have to treat the entire planet like a hazardous waste site. If the surface is toxic and the air is thin, where do we actually build the first city? Forget the glass domes. If you live in a glass dome on Mars, the cosmic radiation will give you a lethal dose of cancer within years. To survive, the first Martians will likely be cavemen 2.0. Mars is covered in massive, ancient lava tubes, underground tunnels left over from volcanic eruptions. These tubes are large enough to fit entire cities inside. They provide natural insulation from the -60 C temperatures and act as a shield against the radiation bullets constantly raining from space. Living in a cave solves the radiation problem, but how do you stay sane when you haven't seen a tree or a blue sky in a decade? Who is in charge on Mars? Currently, the Outer Space Treaty says no nation can own a planet. but it doesn't say anything about private companies. If a corporation builds the oxygen scrubbers, they effectively own your life. If you break a law, there is no police station to call. Do we follow the laws of the country that launched the rocket, or do we create a Martian common law? The first colony won't just be an engineering experiment. It will be a terrifying experiment in human governance. We can build laws and caves, but we can't build a new atmosphere, or can we? To stay alive, we have to use ISRU, in situ resource utilization. We can't bring enough water and air from Earth. It's too heavy. Instead, we have to use the Sabatier reaction. We take the carbon dioxide from the Martian air and hydrogen we bring from Earth, run them through a nickel catalyst, and create water and methane. We essentially turn the Martian atmosphere into rocket fuel and drinking water. This turns Mars from a graveyard into a gas station. Even with unlimited fuel, there is one thing we cannot fix: the gravity. And that's where the story takes a dark turn. Mars has 38% of Earth's gravity. We know what zero gravity does to adults, but we have no idea what low gravity does to a developing fetus. The first children born on Mars will have longer limbs, thinner bones, and significantly larger heads. They wouldn't be able to visit Earth. Their hearts wouldn't be strong enough to pump blood against Earth's heavy gravity. Within just 2 generations, Martians wouldn't just be people living on another planet. They would be a different biological species entirely. The reality of colonizing Mars isn't about saving humanity. It's about watching humanity split in two. One half stays in the garden, and the other half evolves to survive the desert. We are the first generation in history that has the blueprints to leave our home. But the more we look at the red dust of Mars, the more we realize how perfect our own blue marble is. We aren't looking for a replacement. We're looking for a perspective. If we can find a way to make a rock in space habitable, what's stopping us from fixing the paradise we already have? If you want to know what Earth will look like in 500 years if we don't go to Mars, you should watch our video on the future of Earth's climate. Subscribe to MindSpark to help us keep exploring the edge of what's possible. Stay curious.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious.